Okay, nice. Okay. Okay, let's get started. So, hello guys. Welcome to WebHack Meetup. My name is Chen. Sorry. Okay, I untouched something. Okay. My name is Chen. I'm a software engineer in Rakuten, and I'm the host for today's event. Before we start the journey today, I'm going to give you some openings. Okay. This is our today's agenda. We're gonna have 40 minutes for the main session. Our speaker Ansel will give us a talk about an introduction of data engineering. After that, we will have 10 minutes for Q&A and 30 minutes for networking in the end. So don't forget to join the networking session after the talk. As usual, we use AirMeet to host the online event. For people who haven't used this before, there's some unique features you can try. First, you can select emojis at the bottom. Everyone is allowed to click the button as many times as you want. Feel free to interact with us by throwing emojis to us. Also, during Q&A session, you can raise your hand by selecting raise hand button. It will show on the right hand side of your channel of the panel. Once you select this button, we will take your question and AirMeet will bring you to on the stage with us, and then you can ask questions in person. Notice that when you are on the stage, your camera will be turned on. If you don't want to show on the screen, you have to click the button here to turn off your camera. Oh, wait a minute. Give me a second. Sorry. Okay. While we are doing rehearsal, sometimes the raise hand button is actually at the bottom. So it's better you check either at the bottom or the right hand side of the panel. You will see icon just like this. Okay. So you can turn off the camera if you don't want to show on the screen. And of course, if you are as shy as me, you can just ask question in the chat channel. Our coworkers will pick you up and ask your questions instead. And during our networking session, you can grab a seat in this page. As you can see, each table is allowed to have 4 people at maximum. You can select the table you want, talk with other audiences about the talk today, and our staff and the speaker will also be there, of course. If you're lucky enough to get a seat at the same table with the speaker, you can ask him some question in person. And besides, we use HackMD to take online notes. If you would like to collaborate notes with us, feel free to visit this link. Our staff will share the link in the chat channel as well. Okay, yeah, our staff share links. Okay, for some newcomers, I'd like to introduce WebHack Meetup. We are a group of people who are interested in the knowledge related to IT industry. We also enjoy sharing knowledge with other people, so we try to invite different speakers from different fields every time. In the past, we used to host the event at different companies, but due to COVID-19, we moved our events online. We've been hosting this WebHack meetup for over 3 years. There are around 1,700 attendees joined WebHack meetup so far, and we have around 1,100 members in our community. Also, started from last month, we have a series of events cooperating with VMware Pivotal Labs. We've done 2 events already with various topics, and we will have more in the future. Okay, so if you want to get our latest information, feel free to subscribe our YouTube channel and the Twitter account here. Okay. All right. So it's time to introduce today's speaker. Our today's speaker is Ansel. He's a senior data engineer in Treasure Data Tokyo. He has been working in the data engineering field for a long time, so we are very happy to have him give us a talk today. Let's welcome Ansel. Woo!
Thank you.
Okay, give me a second. Let me stop sharing.
Okay.
Okay, it's your turn.
Okay. Okay, could you see my screen?
Yes.
Okay, great. Yeah. Thank you for introductions. Today I'm going to talk about a glance of data engineering. And hi, I'm Ansel, and about my person that I have a lovely families, and I like to go hiking and snowboarding with them. And I'm a senior data engineer from Treasure Data. And also before Treasure Data, I also been working as a data engineering field in Lufthansa and a Taipei-based company, Bridgewell, and a Tokyo-based company, Abeja. Okay, so welcome to connect with me in LinkedIn. And let me briefly introduce about our company, the Treasure Data. We are a data platform company. And besides of that, actually we develop many open source projects and release it publicly. So the most famous is FluentD, which is a log aggregation tool using data injection. And Inbug is also using data injection, but using a bug import approach. And MessagePack is an serialization protocol that allows us to cross-language to transfer data in network. And DeepDeck is one of the workflow management tools that later on we will go through about the workflow management. And Plasma is an not yet open source tool that we use in our storage engine with the Columnar cloud-based. And the same later on we will go through about the Columnar Storage. Okay, so in Treasure Data, we use this tool to build the data platform service and provide to our customers global-wisely and let them to understand their customer better. Okay, that's about Treasure Data. So what about the data engineering? What's the missions of the data engineering? In my opinion, the mission is very simple, is to prepare easy to use data. So let's see what the data that we can have in our service. The first, we define data with schema as the structured data. That means that with schemas that usually can be represented in the table forms and with columns and rows. So besides of structured data, there's definitely has unstructured data that typical unstructured data are multimedia, image, audio, video, or document. And in terms of the data volume, the unstructured data definitely is larger than the structured data. But actually, in my data engineering experiments, we, in more cases, still focus on the structured data. And then where other data could come from? In the analytics that we might have master data, for example, the user profiles or product info or location info. And beside of master data, we might have the other kind of data we call the behavior data. It's, for example, like money transferring, online transactions, or any kind of behavior. So for master data, how will it be updated? For example, the user profile, we might increase new user, and we might have some updates in some attributes of the user, and we might delete it. But on the other hand, the behavior data's update pattern is very different because behavior data, it essentially is the log of the event. So as the time goes and events coming, the behavior data will accumulate and increasing. And one of the properties of this behavior data is once the events already recorded, and it won't get changed. Like your logs won't get any update or change once it already happened. Okay. So one of the most important questions is how large are the data? And the other question is also even more important is how fast are they growing? And typically that the behavior data will be grows much faster than the master data because as long as the time goes and your business keep running, the data will accumulate and maybe accumulate faster than before. So in terms of the data volumes growing, and you have to plan your data retention policies, or you have to plan your system capacity in terms of the data volume. Okay, so that's about the data itself. But how could we achieve easy to use? How do we define the easy to use? First of all, we need to understand how the data will be used. And actually, the data's values come from it answer people's questions and help them to make a decision. So let's see what question people may ask from the data. Yeah, for example, in some easy service that people might be interested in the items in the shopping cart. And in some financial service, people might be interested about the account balance. and marketing people might interesting about the popular item categories. Yeah, and internal analytics, they might interesting about the customer attributes and what kind of customer can bring more revenue. Okay, so above questions are very typical questions people might ask, and we largely can classify them into two types of the question. One is a lookup question, which is more interesting in individuals' details, like a shopping cart or account balance. And the other type of questions, we call it analytical question. It's more interesting about distributions of a group from some attribute, for example, the item category distributions or customer segment distribution. Okay, so assumes we already have our data in a structured form and with columns and rows. So where is the challenge? And the challenge actually comes from once your business growing and become larger and become more complicated, your data set might grow into like this reasonable size, have 1,000 columns and 10 billion rows. Yeah. So with your data size growing and become complicated, then the processing efficiency will become very critical. And one of the most important factors would be how you store the data. So how should we store data? First, we could have the Rowise storage, means in a table form of the data. Table actually just an abstract concept, but in the physical, how we arrange the data, we might have the Rowise storage that we arrange the data cell row by row. So in the underlying, it might look like this. We arrange the data row 1, row 2, row 3 in our storage block. On the other hand, we can have the other type of storage we call the columnar storage. And in columnar storage, we arrange our data cells column by column. So in the underlying storage, we'll put our data in column 1, column 2, column 3, etc. Okay, so what would be the difference between Rowise and columnar storage? Let's see the lookup question, for example, the shopping cart. It was interested in the individual detail of one record or a couple of records. So, for example, in the Rowise storage, if you're going to access one record, that you have to find out the start point, we call the offset, and read it through the storage block. But if you are store your data in the columnar storage and you are going to access one record, that means you have to go to column 1 and column 2 and column 3 to get all your data. So you have to jump many times between the storage block and read many blocks and cost a lot of overhead compared to the Rowise storage in this case. Yeah. So the difference from these two graphs might seem not too much, but you have to keep in mind that if we are dealing with the 1,000 columns and 10 billion rows, there will be a huge difference. Okay, so how about the analytical query? For example, the item category distribution, we might only need one column, the category column, or a couple of columns. Yeah. So typically the analytical questions, the interesting attribute of the analytical queries is like 5 attributes or 10 attributes compared to the whole data set. You have 1,000 columns. It's a very small portion of the attribute. So if you are going to access attribute in the columnar storage, it's quite simple. You just need to find out the column offset and read through it. But again, if you're going to access all the attribute, you are going to access one attribute for all the records, then you have to jump between different records storage block and seek many times and cause a lot of the reading head moving overhead and reading storage block overhead. So now we can understand why the columnar storage is efficient for the analytical query. But what's a limitation of the columnar storage? One of the most important limitations is the record update, including insertion or deletion. So imagine now we are going to update a record in the columnar storage. Then where should we go to update? Yeah, again, we have to jump in. We have to jump in every columns and update many storage blocks, and it's very expensive. So now we understand the columnar storage is efficient for analytical query, but have to pay very high cost for the record update. So is it possible for us to restrict of the record update of the data set? Yes, and these restrictions actually will turn the data set into immutable, means it cannot be updated. So is this really useful in some use case? Remember we have the behavior data before, mentioned previously that it was only do the append with the new coming event. So the very common approach for the behavioral data set turning to the immutable data set is we will divide into time segment. For example, the first hour's data, once the first hour's times come in, we will know there's no new data coming to here. So we can safely compile them into an immutable data set. And so down the next hour and next hour, and as the times go, we will accumulate the small partitions of immutable data set. Okay, so here comes a very common use case is the behavioral analyze. So for behavioral analyze, because we're going to analyze behavioral data, so that means the behavioral data can convert in with the append-only immutable data set. And because of each of the small unit is the immutable data set, so it allowed us to use the Columnar Storage to store this data. And so it results in the Columnar Storage can benefit for the Analytical Query and provide very high efficiency compared to the Rowise Storage. Okay, so that's examples of the behavioral analytics and how we can make it easy to use. Then next, let's move on to the process of the preparation. So how we prepare the data. First we have to understand how the data flow from the source to user. And we will call it data flow. And in the enterprise, the data flow might look like the networks and very complicated. But basically, we will have the data source, external source, for example, some web application service and some customer or users import data or some external database. And for the input data, then we also have some data users internally or externally, for example, the dashboard, some external database, and some ad hoc user query or daily report, for example. So from the input to the output, we also will have many intermediate states in the middle. Okay. So for the first part, sorry. So for the first part, that we will have the data injection, and data injections we define. Sorry, wait a second.
No worries. You can wait.
Sorry.
Correct?
Yeah, I'm back.
Okay, nice.
Okay. So for data injection, we defined as a component that injects data from our systems external to internal. Okay. So the injection components, we can have push-based injections. Push-based injections means the data provider trigger a data sending request and send data to the data receiver. And in this case, that usually means our data receiver need to run kind of service and ready for the data provider's request. So on the other directions, we could have the pull-based injection, means the request is triggered from the data receiver and it sending the request to data provider to fetching the data. So that also means your data provider need to run kind of service to ready to serve the data fetching request. Yeah, the most typical question is a database. Okay, so either the push base or the pull base, you need to run the service on the provider side or the receiver side, and you also have to have build up the connections between the provider and receiver. So actually there's another very popular pattern we call the publisher-subscriber pattern. It will run the service in the middle and to offload the responsibility of running the service from each side. So in your data provider side, you don't need to run any service. You can use the push base to push to the publisher subscribe, we call the broker. And for the data receiver side, you also don't need to run any service. You just use the pull base to pull the data once you're ready to process the next one. So this patterns has the advantage that it offload the responsibility of the server service, and also it decouple the provider and receiver and provide very large flexibility in the data ingestion design. So for example, the flexibility actually, if your data provider and receiver even already has a service running, you still can use an agent in the middle and adapt them with the publisher subscriber model. Okay, that's the injection part. So let's see how the data flow to our data user. So for example, we take the ad hoc query as an example. You might be experienced that writing a very complicated SQL statement and have 100 lines and joined and aggregates. So your transition might be very complicated, and we'll code the data from the storage to your hand. We will call it a read path. So if you're going to go through many intermediate state, and we will think your read path has a very long. And so if your data set is reasonably large, then it might take very long time. Yeah. And on the other hand, the write path we defined as a data that from inject to your data storage. For this example, we have these three tables stored in the storage. Yeah. So what can we do for this situation? Actually, we can pre-generate the intermediate table or intermediate state. And by this pre-generation, that every time the query come in, we don't need to start from the beginning. We can start from the middle so that our read path will be shorter. That means your response will be faster. Yeah, but you have to pay the cost that your write path will be longer. You have to pre-calculate. And of course, we can further push the boundary to the right and to make your read path very short, but again, your write path will be long. So once your read path being very short, your request will respond very quickly. And this is one of the motivation that provide us to prepare this intermediate state. Actually, we have other motivation. For example, in the enterprise, we might have many use cases. And this use case might share the same intermediate state. So the pre-calculation of this intermediate state actually will saving a lot of computing resource, and also have a quick response. Okay, so we will call this part the preparation of the intermediate state. We'll call it transformation. Each of the stage is one transformation, and the whole flow we will build it with the data pipeline. So in the data pipeline, what would be the challenge and what's the trouble we might face? The first is because the transition might have so many stages, like hundreds or thousands of the transition process. So it will have certain chance that some transition just go fail by any reason. Yeah. And the other common trouble is you have some bad data from the data source, and the bad data will go to pollute your downstream data, and this is actually very troublesome thing. So for the data pipeline, what is the must-have? Yes, we must have the monitoring and alerting to help to ensure the data quality and detect any failures. So besides of the monitoring and alerting, we also are relied on the workflow management tools a lot, because that's so many transformation stage, they have dependency, and the workflow management tool actually is manage the dependency for us by modeling the dependency with an direct acyclic graph. And with the workflow management tool, we can have more automatically to schedule the pipeline runs, or to do the recover, or to see what happens in the transition with the visualization tool they provide. So for the for workflow management tools, it provides us the pipeline retry functionality, but we actually will need to implement the transition process by ourselves. So for in the transition process implementation, one of the most important property is once the downstream data generated, it might have been retried by the workflow management tool. So we want to keep the downstream data consistent, and we will call this property the idempotent. Means your transitions, no matter how many times your transition runs, your downstream data won't get any change, won't get any duplication. Yeah. So that's one of the most important property that we want to keep in our transformation stage. And actually, the requirement of the idempotent, yes, you have to protect your source data to become immutable. Yeah. So actually, our whole data pipeline, every stage, we will hope they keep immutable, so that our whole data set will become very consistent and stable. Okay, so in the data flow, what else of the important requirement that we have to consider? Yeah. So how quick we want the data being visible by our data user is also a very critical requirement. For example, in the transition, we could have a daily schedule to schedule the pipeline and transformation. But that also means our data users will have up to 1 day's delay. And sometimes there's not acceptable. So we might be able to increase the frequency to hourly, but processing a smaller batch of the data. So we will call this periodical schedule transformation. It's a batch processing. And actually we can further to increase the frequency to 5 minutes or 10 minutes, we will call it mini batch process. And it will provide more timely data, but with the smaller batch process also means might be less efficient. So to extremely, actually, we can have, once the event come in, we can just process it and send to next stage. So this becomes more like an event trigger, but not the periodically processing. And this approach actually can provide the most timely result, but what's a limitation of the streaming process? Actually, in the join logic, that usually you might have to wait for another data source and have some delay window. Yeah, but in the streaming process, that your delay window might not be able to set as large as the batch processing. So in this situation, that we generally believe the accuracy of the streaming process can provide is not as good as the batch process. So here we come an architecture that allowed us to combine batch processing and streaming processing, and to combine the advantage from both sides, and to provide accurate and also timely data. For example, in the dashboard, you might have the data up to yesterday come from the batch processing, and you'll have today's live data from the streaming processing, and you might be able to lively update it in any time. And once the times go to tomorrow, then today's batch process will update today's number, and you will have the tomorrow's live data like this way. So by these combinations, you will get timely result, today's and accurate historical number. Okay, so we basically go through our data engineering mission, prepare easy to use data, by understanding the data structure and also understand the properties of the master data or behavior data. They have different update pattern. And the important question is, we need to understand how the data will be used, what kind of question the data will be used to answer. And for lookup queries and analytical queries, it might suitable for different storage type, Rowise or Columnar. And here I give some example. Rowise actually the relational database, they basically use the Rowise Storage. PostgreSQL, MySQL, they are database, but their underlying storage engine, InnoDB, they are using Rowise. And Columnar Storage, famous examples are Apache Parquet or Kudos. And you also can search for any alternative from this keyword. And in the behavior analytics use case, we understand the behavior data can convert with the immutable append-only data set and use the columnar storage to provide analytical query very high efficient. And in the data flow, we go through the ingestion part, and we introduce the publisher-subscriber pattern. And the most famous publisher-subscribe pattern is the Kafka, Apache Kafka. And the Fluentd bug is from treasure data. We can use it as an agent. And also Logstash is also a popular agent. And for data pipeline, we understand we need the monitoring and alerting. And there are so many tools that doing these things. You can search for GraphNode, InfluxDB is a time series database underlying, and Prometheus. Yeah, you can search start from this popular tool. And for the workflow management tools, we understand it use the DAG, direct acyclic graph, to help us to manage the data pipeline transformation. And we know we want to keep our transformation idempotent so that it will become retrievable and won't ruin your data. So the workflow management tools are most popular might be Apache Airflow by Airbnb, and also there's Luigi's and DeepDeck is from treasure data that we use daily. And for the for different requirements from your data user, you might adapt to streaming process to provide most timely data, or use the batch process to provide use your system resource efficiently and provide accurate data. Or you would like to combine them with Lambda Architecture to have the advantage from both. So the common tools, the most historical is the Hadoop MapReduce, Presto for the batch process, and Spark actually provide the two types, Spark Streaming and Spark SQL for batch. And Flink is the design for the streaming. Okay, so the last one is I think is the most important keyword for the data engineering doings in the data design. Yeah, we have to plan this word in our head. The scalability. Every component of the data system needs a scalability. Okay, so that's my presentation today, and thank you for your patience.
Oh,
let's have some question.
Great, thanks Ansel for giving us such an interesting talk. I believe this talk gave our audience a whole picture of data engineering. So yeah, let's go to our Q&A session.
Okay.
For audience, if you would like to join our stage, you can click the raise hand button should be at the bottom. We will pick you up, and then you can ask questions in person and having discussion with our speakers. Is anyone want to ask questions related to our talk? Oh, yeah, I saw it. Okay. Hi, hello. Hello, Pipo.
Hey, hello. Can you hear me?
Yes.
Yeah. First of all, thank you for your great presentation. And
Thank
honestly,
you.
I'm totally newbie to this. I know nothing about data science, but your presentation, I noticed you mentioned a lot about immutable and idempotent. I'm wondering, like, in data science, how do you guys enforce this immutableness and idempotence, like at the language level, or like using any kinds of tool?
Okay. Yeah. So for the idempotence that it says, let's go back to a little bit. Yeah. Can you see my screen?
Yes.
Yep.
Okay. So for the idempotent, we said the transformations won't change no matter how many times you execute this. So actually, in our practice, the simplest way is to isolate your each batch job's destination into different partition. Yeah, for example, the first because the transitions usually is scheduled in the workflow management. For example, the hourly. So your hourly output, we were trying to keep that isolated, maybe isolated by the output directories, so that every time we are going to do the transition, we just clean up the destinations, the destination directory, and generate a new batch. This is the most simplest way. Yeah, and okay. So for the example, if your output is some database, then you might also be able to use a partition functionality and to direct your transition from different time to different partition. Yeah, that's the most wanted situation and allow us to do the idempotent.
I see. And one follow-up question is, during the transition pipeline, how do you ensure your data is not mutated along the way?
You mean immutable?
Yeah. How do ensure immutable?
Okay. So, yeah. So actually, it starts from the beginnings of the how the data flow and pipeline. So from the beginning, if your injections are idempotent, that means once your data generated, then it won't change, right? Once your data generate for one, okay, it won't change. And so if your source are stable and your transition are also stable, that means your generated intermediate state will also be stable. So it will become like this. So the key point is you have to ensure every part of the transition, including the injection, are keeping the idempotent principle.
I see. Understood. Thank you.
Okay, thanks, Bible. Do we have any other audiences want to ask question? Oh yeah, I saw it. Cool. Neil. Okay. Neil, wait a minute.
Hello.
Hello, Neil.
Yeah, thank you for the great talk. I'm wondering about the Lambda architecture. Like, if you want to achieve the Lambda architecture, does it mean that we need to double the computing resources? Like, originally, we just need one pipeline. So when we want to do the Lambda architecture, we need to double the computing resources.
Yeah, sure.
So,
okay.
Sorry. Yeah. I'm wondering, is it possible we can reuse the result from streaming process and input of the batch process, or is it sounds ridiculous?
Okay. Yeah. Actually, previously I mentioned the advantage of the Lambda architecture. Yeah, but of course you have to pay some cost. Yeah, one of the costs is you have to double the computation. Yeah, because you're going to run two pipeline, and also you have to maintain the two copy of code if your streaming framework and batch framework is not fully compatible. Yeah.
Okay.
So that's a cost that you have to pay. So actually because the cost is kind of significant, so usually we won't implement our whole system as a Lambda architecture. We will only implement as less as requirement of the Lambda architecture. Maybe some very critical live report, live dashboard will be used it. So actually the streaming part is usually not as large as the whole batch part, will be a smaller one. So for the streaming part, yeah, that's the duplicate resource usage of the batch processing. And as my experience that we will never want to mix them together because we try to keep our data and system as clean as possible.
I see. Cool.
So I hope this answers your question.
Yes. Thank you.
Okay, and so we have a question from the chat channel.
Okay.
So, it's a question from Steven. He's asking about for the publisher subscriber pattern, should we consider the broker's disk space? It may happen if the data generated by the publisher far more than the subscriber consumes, or the broker won't drop the data when the subscriber consumes. Will that be a problem?
Okay. Yes, that's definitely is an important problem that we should consider. Yeah, but again, that the keyword that I mentioned at the end of the talk is scalability. So for the broker cluster itself, yeah, we hope it will as much as scalable as possible. So once the capacity is enough, then maybe the disk is enough, which we can extend it very quickly and easily. Yeah, but again, if your consumers consuming power is not enough to consume all the incoming data, then you will inevitable to have to drop some data in one day, unless you can extend unless you can scale up your consumer power.
Okay.
Okay, thank you.
Okay.
Hmm.
Have more questions? Actually, personally, I have a little questions for your talk. I'm also not so familiar with data engineering, but I'm interested in the batch process and streaming process part.
Yes.
As I understand, streaming process is just like the mini batch process. Is that right? Like,
the idea is a little bit different. The streaming process is more like processing data one by one.
One by one. Oh.
Yeah. And the mini batch is still processing data with a time frame, but smaller time frame.
Ah, okay. Because I was what I wanted to ask is like the window size of the streaming process, but as answer from you, the streaming process is actually processed one by one, so it doesn't have anything deal with the window size, right?
Yeah.
Okay, understand.
Yeah, but if we are going to do the join, and yeah, you have to deal with the window size, because join is usually involve some delay window.
So it also happen in for streaming data, or for streaming process.
You mean the window size?
Yeah, the joining part.
Yeah. You mentioned. Yeah, in the we still need to consider the window size, and larger window can allow you to capture more data but have more delay.
Okay. So for this kind of streaming process, we have little delay, but it depends on the product. Maybe we can accept it. Okay.
Yeah.
Nice. Can we have one more questions? Because some people is asking in the chat channel.
Yeah, I thought.
Okay. Yeah, he's asking like.
Need to worry about data cleansing. Yes, definitely. Yeah, actually, the data cleansings will be including the data pipeline and transformation. So usually, once the data comes in, we will do the first transformation. We will do just the data cleansing. Yeah. So to ensure all the downstreams of the data users can use the clean data.
Okay. Yeah. Does that answer your question? Okay. Okay. Actually, we're a bit running out of time. But yeah, we're gonna have like 20 to 30 minutes for networking. So please just stay. I will end this session so that AirMeet will redirect us to the social launch page. Our speaker Ansel will also join the networking session. So if you have any other questions, just feel free to find him there. Ansel, you will be there, right? I didn't ask you. Okay. So thank you guys for joining today. we're looking forward to seeing you guys again in the next meetup. And let's move to social launch. Okay. Bye bye.
Okay.